So this is day 2 of our notes. Yesterday we talked about how to solve things in function notation. Today we're talking about how to graph those things in function notation. So on the first page of your notes you have bell work. That is going to be, what we did yesterday. So if you want answers to that, I'm just going to try to make this video a little bit shorter. If you want answers to that, go ahead and go to Canvas, go to modules, and check the notes, because the notes I have filled out on there show the answers to these. Okay. So we're going to move on to graphing a linear function in function notation. So we've talked a lot about graphing, and I mean a lot about graphing. Now, yesterday I talked about how the f of x is just y. So we're just going to assume that it's y, and it's our y-axis. So that's all. I mean, typically when you have a function like this, we always check to make sure it's a linear function. Well, in Algebra 1, it's probably going to be mostly linear function. So that tells us that it's going to be a straight line. It's going to have a constant rate of change, right? We've kind of talked about that before. So in this situation, we are taking all of our x's, and we are plugging them in for this x. So that way we can find our y value or f of x value. So, first one, we have 2 and negative 2 plus 5. The first thing I do want to talk about, though, is when you are graphing, not every time, in fact, most of the time, you're not going to get a table like this. So I would recommend possibly making your own table. And I would recommend using negative 2, negative 1, 0, 1, and 2. And the reason I say that is because those 5 points are typically found on the coordinate plane. Whereas if you do 0, 1, 2, 3, 4, 5, your last points won't be found on the coordinate plane. So we have options here. We can either graph all 5 points, or technically, since it's a linear function, what you could do is only graph 2 of the points and connect them in a straight line. But it's more hard in that situation to figure out whether you're right or wrong. Whereas if you do 5 points and they're all in the same line, then you might know that you're right because it's a straight line. So let's start with negative 2. We plug negative 2 in for x. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. Okay, let's do the next one. 2 times a negative 1 plus 5. 2 times a negative 1 is a negative 2. And negative 2 plus 5 is 3. Now, again, we've talked about this. We've talked about how in a linear function, it's going to have a constant rate of change. So after we get to our second one, our rate of change here, from 1 to 3, we add 2. We can really just fill in the rest of the table. We don't have to solve the equation multiple times. So what I would do is just add 2 to 3, which is 5. We know 5 plus 2 is 7. And we know 7 plus 2 is 9. So we know all of our points, right? We know we have negative 2, 1, negative 1, 3, 0, 5, 1, 7, and 2, 9. Those are the points we're going to graph on the graph. So I'm going to go ahead and write those up here so when I scroll down, I'll still know what the points are. So negative 2, 1. Because remember, x is before y every time. We have negative 1, 3. We have 0, 5. We have 1, 7. And we have 2, 9. So now we know what the coordinates are. Let's just graph them. Okay, so on a coordinate plane that looks like this, we just graph. So we started our origin. We have negative 2 and 1. Negative means we go left, so we go left, 1, 2. Positive 1 means we go up 1. That's our first point. Okay, the second point is negative 1, 3. So you go left 1, up 3. Our third one is 0, 5. So that means we do not move right or left. We just go up 5. Okay, our next point is 1, 7. That means we go right 1 and up 7. And for 2, 9, we go right 2 and up 9. Okay, we notice that all of our points are in a straight line. That means we are correct. Now all we have to do is draw our line as straight as we can with an arrow on both sides. If you do not put an arrow on both sides, you are not telling me that is a line. You're telling me that is a ray, or maybe an in-between value. So make sure you put an arrow on both sides, because we know lines go on forever and ever and ever. So in this situation, it's a line. It's a linear function, it's a straight line, so that means it's going to be going up to infinity and down to infinity. That means it's not going to stop moving. So that's our first graph. Okay, our next one is going to be a monitoring progress. If you're in my class and you have notes, at the bottom there's a bunch of tables. These tables are for the graphs. If you are not in my class, just make your own table up here. Go ahead and pause the video and try to graph it, and then I'll cover it and we can go over it. The tables are not visible. I'm just going to tell you what coordinates you should have gotten. So, for number 6, the first coordinate you should have gotten was, if you plug that -2 in, plug the -2 in. -2 times 3 is a -6. A -6 minus 2 is a -8. So your first point should have been -2, 8. Your second point should have been -1, -5. And at that point, you should have known them to went up by 3 every time. So you should have had 0, -2. You should have had 1, 1, and 2, 4. So when we graph those points, all you have to do is start with your top one, -2, all the way down to 8. Okay? Our second point was -1, 5, so left 1, down 5. 1, 2, 3, 4, 5. Our third point was 0, 2. So we're on 0, we go down to -2. Sorry, 0, -2. Okay, our third point was 1, 1, so that means we go right 1, up 1. And our last point was 2, 4, so we go right 2 and up 4. 1, 2, 3, 4. And if you notice, it is a straight line. So go ahead and draw your straight line. You should be covered. Okay, the next one was a little bit more tricky. The next one, if we try to plug in our -2, so we'll say we're plugging a -2 in for x. Now remember, we've talked about this before. If the x is already negative, you have to make sure you keep that negative there when you plug it in. So really what that's going to look like is we put our negative and then we plug our -2 in and have +4. Remember, diver dude makes it a positive, right? Or you can also just remember in your head, when you see a negative variable, whatever you're putting in there, you put the opposite of that. So like an opposite of a -2 is a +2, right? So we have 2 plus 4, which is 6. The same thing's going to happen for a -1. When we put a -1 in there, it becomes positive. 1 plus 4 is 5. And at this point, like I said before, we should be able to tell what our rate of change is. We know that we're going down by 1. So every point we make is going to be down by 1. So 0, 5 minus 1 is 4. 1, 4 minus 1 is 3. And 2, 3 minus 1 is 2. So those are our 5 points we're going to graph, right? So we start -2, 6. So we go left 2, up 6. 1, 2, 3, 4, 5, 6. Okay, we go left 1, up 5. Left 1, 1, 2, 3, 4, 5. Okay, then we go 0, 4. 1, 3. Right 1. Oops. Right 1, up 3. Okay, and our last one is 2, 2. So we go right 2, up 2. If you notice, these dots are pretty close together, but it's still a straight line. Going down, it's a negative slope. And as long as you have 5 dots in a row, you're going to have a straight line every time. Okay, we're going to move on to the last one. The last one's going to be kind of tough. Okay, we're moving on to our next one. Example 5, this one's going to be kind of tough. So, we have a graph for the first flight, and we have to find something about the second flight that it's asking us to find. So, first of all, the graph shows the number of miles a helicopter is from its destination after X hours on its first flight. So that's what this shows, right? We know that right here. We know that right here, they were 300 miles away. And we know they finished their flight at 3 hours. So that means at 3 hours, their miles were down to 0. So we know that this flight went from 300 to 3, or it went from 300 to 0 in 3 hours. That means it's going 100 miles per hour. So now we look at the second flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function is here. That's the function it gives us, right? It represents the second flight where f of x is the number of miles. So this is the number of miles, right? Okay? And x represents hours. So x represents hours. So we know our domain in this situation is going to be hours because our domain is our input, right? Okay. Now we have two ways to solve this. Either A, we can write a separate equation and solve it that way, which is going to take way less time. Or B, we can graph. We're going to do both. Okay? So in this situation, we are given our function. We have 350 minus 125, and we are plugging 0 in for x. So 350 minus 0 essentially is 350. Okay? Now we do 1. We have 350 minus 125 times 1. Negative 125 times 1 is negative 125. 350 minus 125 is 225. And again, we know it's a linear function because we have y equals mx plus b, right? So now we know that we can find a rate of change. We know that when we went from 350 to 225, we're subtracting 125, so that means every single one after that's going to be minus 125. So 225 minus 125 is 100. And 100 minus 125 is a negative 25. Now, right now, you should be able to tell that obviously it's going to finish before 3 hours because we have negative 25. But we're going to graph it just because, so we can compare our graphs. So, we know our domain was our hours, which means our x-axis has to be our hours as well. So our x-axis is hours, our y-axis is miles away. Okay, we're 350 miles away, so I'm going to go up by 100s. Okay, and we had 3 total hours. So 1, 2, and I'm going to put 3 up here. That way it's easier for you guys to see what our graph looks like. Okay. Now remember, the points we found first was 0 and 350. We were 350 miles away at the 0 hour mark. That's how far we started away. Now at the 1 hour mark, we subtracted 125 to get us to 225. So right about there. For the second hour, we got to 100. And in the third hour, we got to a negative 25, which would be right around there, right? When we draw our line, we notice that first of all, it crossed before 3 hours. That means it took less than 3 hours for this flight. So we know that flight 2 is faster. And the reason it's faster is because it took less than 3 hours to reach its destination. The second thing we know is if we go back to 3.3, I kind of want to discuss this part a little bit. We know that our domain was hours, and hours is continuous because you can have a fraction of an hour, right? The second thing I want to talk about is we don't need to draw our arrows on both sides because we had a start point and an end point. We already know from the beginning that we're starting at 350 and 0 hours, and we're ending at 3 hours. So this is not going to continue on forever and ever. So this is a continuous domain, and there's a limit, there's a max. We stop at a certain point. So another way that you guys can solve this is without graphing. We know that our equation was, I think it was f of x, equals 350 minus 125 X. Okay. So up there, it talked about what miles represented, and our miles away was represented by f of x. So if we're trying to find the amount of hours, which was x, all we have to do is put a 0 in for the miles, because we know that once we get to 0 miles, we've reached our destination. So let's figure out how many hours it takes for that second flight. So we put 0 in, got 350 minus 125x. If we solve this, we just subtract 350. Which gives us a negative 350 equals a negative 125x. And now you guys should know, all we have to do is divide by a negative 125. And we should get our hours. So once you divide that, you're going to realize that flight 2 took 2.8 hours, which is obviously less time than 3 hours, so we were able to say that flight 2 is faster. So again, you have two options here. You can either graph and compare your two graphs, or you can put 0 in for the thing that you're trying to find, and you can find how long it took. And we know that 2.8 hours is less than 3 hours, so we know flight 2 is faster. Again, if you have any questions, go ahead and you can either email me or ask me in class.